Good morning, boys and girls. This is Mr. Giomini. I feel like I haven't made a video in at least a year. Well, I guess I haven't since change of year. Oh, I'm so clever and witty. Anyways, enough with the jokes. Let's take a look. This is lesson 6.3, the Pythagorean Theorem. We talked today about this fancy little formula here. A squared plus B squared equals C squared. And remember, this only works with a right triangle. So the triangle must have a right angle in it in order for this to work. Now we will see some other examples of how you can also do this and make a right triangle. But I have my right angle right here. It's at the vertex C, point C, in triangle ACB. Now we have the A. That is always a leg. B is a leg. And C is the hypotenuse. And just to save time, I'll call it the hyp. Now the hypotenuse is always opposite the right angle. So if I'm looking at this, I have this would be a leg, this would be a leg, and then this, because it is opposite the right angle, is my hypotenuse. So let me change colors there, and it doesn't stand out enough. Let's try that. There you go, red. There's my hypotenuse. So if I am looking at this, they give me one of the legs. They don't give me this leg, and they give me the hypotenuse. So I'm just going to call, it doesn't really matter if this is A or this is B, because it's addition, it's commutative. So A squared, so I go 4 squared, so substitute in 4 squared plus B squared, which we don't know, we're trying to find out, equals C squared, which is 10. Now I'll just square these. That gives me 16 plus B squared is equal to 100. I'm trying to solve for B squared, so I'm going to get rid of the 16. So I will now subtract 16 from both sides. Subtract 16 from both sides, because whatever I do to one side of the equation, I do the other. That cancels that out. I'm left with B squared is still over here, is equal to 100 minus 16 is 84. Now, because this is squared, I want to find the square root of each of these. Simplify this 84. This just becomes B. Now, here's the tricky part. I don't really know the technical way of how you would phrase this, but when I see 84, I think of it this way, and I think of my prime factorization, breaking this up. First thing I see is an 8 and a 4. I know 4 goes into both, so I'm going to do it like this. So 4 goes into 84, it would be 4 times 21. Now, I look at both of these numbers and see if either of these are a perfect square. 4 is indeed a perfect square, so the square root of 4 is 2. So that becomes a 2. Now, it's times, just like this is 4, square root of 4 times the square root of 21, times the square root of 21. Now, looking at 21, can I break up 21 in any factors that are perfect squares? 3 and 7, neither of those are perfect squares. There's my final answer. So B would equal 2 times the square root of 21. Okay, now in our textbook, many of the examples won't be like this, but when you're doing your con practices, this is what it'll look like. This will actually kind of simplify it down to this. Let's take a look at another one here. I have A squared plus B squared equals C squared. That's how we start the Pythagorean Theorem. I have my 2 legs. I'll go over these legs real quick. Here's one leg. Here's the other leg. I know those are both legs because they are both adjacent to the right angle, which is at vertex C here, and opposite that is the hypotenuse. I can tell that the hypotenuse is line segment AB. So here is my hypotenuse right there. That's 8. So let's substitute it into this formula and see if we can't figure out what this missing leg is. So we have A squared, we'll call that 3. 3 squared plus B squared, we don't know what B squared is equal to the hypotenuse, which is 8 squared. We'll simplify this. We know that 3 squared is 9 plus B squared, we don't know, equals 8 squared is 64. Okay, now what I'm going to do, I'm just going to simply get rid of this 9 because I want to get all the whole numbers to one side of the equation, the integers on one side of the equation, and get this B squared by itself. Make that equal better. So I'll subtract 9 from both sides. I'm left with B squared is equal to, let's see, 64 minus 9. 64 minus 10 would be 54. I have one less, so that's actually one more, so that's going to be 55. as we did in the previous example, we want to see if we can find the square root of both of these. Well, the square root of b squared is b. Now I'm looking at 55. Okay, as I did in the last one, again, I don't know what the technical rationale for this or terminology is, but I'm going to try to break this into its prime factors. And it's 5 times 11. And that's really the only thing. And neither of these two numbers are perfect squares. So I'm going to leave my answer as b is equal to the square root of 55. Hope this helps you out. Have a great weekend, and we will talk to you next week. Take care. Bye.